Hey everyone, today we're gonna be doing a lead code question which is to find the first smallest positive number that is missing from the array. So we are given some array, we need to find which is the first smallest number which is missing in this particular array. We need to do this in a constant space and the linear time. So let's see what are the constant are given. So number can go, you can say the element in the array can range from 1 to 10 to the power 5. Like this can be the size of the array. So minimum there can be one element and it can go till 10 to the power 5 as a maximum element. Number can be positive as well as negative. They are saying like number can go from minus 2 to the power 31 to positive 2 to the power 31. Okay. So we need to find what is the smallest positive number. So if you see 0 is not a positive number, minus 1 is not a positive number. So what we are doing, like we are starting from 1. Like I'll show you with example like how to do this. So let's take the example first. Like we have some array, 1, or you can say I have this array 1, 2, and 0. What we need to find, what will be the first smallest number which will be missing. So if you see, the first smallest and positive number can start from 1. So I know my starting number will be 1. So my starting number will be 1 because this is the first number which is positive, even small. So I know my number will be starting from somewhere this position, and I don't know how far it can go. So let's see here. I'll just check. Okay, is 1 present? Okay, it's present. Is 2 present? It's present. Is 3 present? No, it's not present. So I know we need to something search, and like we need to do what searching over the array. We need to find is my number present or not. So I got one point, our first value will be starting from 1. Like our the starting, you can say first missing number will be 1. Like it will be starting from 1. I don't know which will be the missing number, but I'm sure like it can be starting from 1 because it is the positive number and it is the minimum number. So, okay, I'll see. This is my start position. I need to find how far it can go. So I got one thing. Either it can go till the maximum number or it can go till maximum size. So by seeing this example, I'm not sure what can it be. So if I say the answer is for this example is 3 because 1 is there, 2 is there. The coming up 3 will be our answer. So okay, I can say it can go till size of the array as well. Another, I'll take the another example, which is 3, 4, minus 1, and 1. Okay, this is also our array, and this is also our like equation. What it can do, it can start from 1. Just check 1 present. Okay, present. Is 2 present? No, 2 is not present. Let's see what element it can go till at max. For searching in this array, I can say, okay, I can go from 1 to 4 as a minimum to maximum, and I can see, not minimum, my start point is fixed. I can start from 1. How far I can go? I can go till maximum size, or you can say the maximum element. Either it can go till the size of the array, because if you see something in between, if I have also like 1, 2, 3, and 5, if you see the size of the array is 4 here. I am just checking, okay, 1, 2, 3. Yeah, 4 is missing in this case. So I got to know either I can take the maximum element or the size of the array. So I got the second point. First point is this. Second, the ending, or you can say maximum value can be, or you can say ending point. Ending can be max element or size of array. I can take any of them. Okay, these 2 points are fixed. I need to iterate from 1 to maximum element or the size of the array and need to find which number is missing. I'll just simply take my array. Okay, 1 is present, 2 is present, 3 is not present. Okay, return 3. I'll start from here. I'll say, okay, 1 is present. Okay, present. 2 is present. No, 2 is not present. Return this array. If I show you one more example, there is one example like something starting from 7, 8, 9, 10, 11, 12. So what you say, okay, maximum number is 12. I can start from 1, I can go till 12. But if you see, the size of this array is like 0, 1, 2, 3, 4, and 5. So size is 6. It is starting from 1. How far it makes it can go? So if you see, something is missing in between before the maximum size or maximum element. If you say, if I have 1, 2, something, 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 or you can say this is the missing part, I directly have 8. So what will be better to search? Till 1 to maximum number or 1 to size of the array? If you see, size of the array is like searching very less. If something is missing in between, it will be surely coming in this picture. So I can say, okay, I will be picking my size of the array as the ending point. So I got my first approach. What I need to do, the very brute force approach, I can start from 1, I can go till maximum size or the size of the array. I can see, ask, is array 1 is present or not, 2 is present or not, 3 is not present. Whichever is not present in this range from 1 to maximum length or from 1 to size of the array, that will be our answer. So in this case, okay, 1 is there, okay, there, 2 is there, no, 2 is not there, the 2 is our missing number. In this array, 1 is there, 2 is there, 3 is there, 4 is not there, 4 is our missing number. In this example, first is not there, so first is our missing number. So I got my very brute force idea. I just iterate from 1 to n. Iterate, if you say my approach 1, iterate till 1 to size of array and check if it is present or not. Check if present. If it is not present, just return that number. So this is our first approach, but the time complexity is n square for this case because we are just searching 1 to size of the array, and for searching that number, like I will be repeating again from that elements in the array. So for each number, like for 1 I'll search entire array, for each, like for 2 I'll search the entire array. So time complexity is n square, which is very high. I need to optimize somewhat, like much lesser to this. So let's reduce to one part. What I need to do, if I reduce this, it will be coming somewhat n log n, the one step lower to this. So if I need something time complexity n log n, I know one thing, sorting have this time complexity. So what I can do, like, okay, I can use this array, I can sort this array. So if I take this example 3, 4, 1, I'll take this example 3, 4, minus 1 and 1. If I sort this array, it will become minus 1, 1, 3 and 4. I again need to like search, is 1 present or not, 2 present or not, 3 present or not. But instead of that, I know one thing, my starting point, or you can say my missing number is fixed. My missing can be starting from 1. Let's think, I assume my number is missing, like my first value will be 1. So I'll say, okay, missing number is 1 at the initial. What I'll do, I'll iterate over this array. As it is sorted, I'll get the number in the order, in the sequence. So I'll iterate over this array. I first found the negative number or 0 or something. I can ignore that part. Okay, my first element was this. Ignore because it is negative. Second element is this. I'll say, is it equals to missing number? Yeah, it is. So I'll say my assumption was wrong. My next can be 2. My missing number can be 2 in the next case. Okay. I like my first value was this, second was this, I got this, like it is not a missing number. I'll iterate again. My number is 3 in this array, and I assume my number can be 2 as a missing number. So it is not equal now. So my assumption was right. Okay, the missing number is 2 and I proved it because number came now 3 and I assume it will be coming 2 as a next. So it is not equal. I'll say, okay, return the maximum number. So return the missing number. So I'll return this one. Suppose if we have something like the first example 0, 1 and 2. If I sort this one, it will become 1, 2 and 0 like this. If I iterate over this array, I started over here, it is a negative or 0. I'll ignore this part. I assume my first as a missing number. So I've taken missing is 1, first case. So it is our start point. I'm sure it's fixed. It will be starting from 1. Okay. I iterated over here 0. No, it's not positive. I iterated. I got 1. I compared. 1 is missing. No, I already assumed it is not there. I increment this. What? My next can be 2. My next missing can be 2. I just incremented the value. Again, I iterated to the next value. Is 2 equals to missing number? Yeah, it is. But I thought like it can be missing. It's my like my assumption is still wrong. I increment this one. Next can be 3. Now I have entirely iterated over this array. I don't have any iteration left. What I can do? At last I can return, okay, next I can return the missing number. So whatever is now in this array will be our missing number. So suppose if you don't have an array, so I just assume 1 as a missing number. I can simply return, okay, if nothing is there in array, missing number I assume already it's 1. So just we need to find which is missing in this array. I just increment my value. If it is equal, I again increment. If it is equal, I again increment. If something I don't found, like in this case, I don't found 2, so 2 is our missing number. I return from here. So this is having time complexity and log n, but we need to still optimize because in the question they are saying we need to do in the linear time and in the constant space. So let's reduce one step. What we can do, I can reduce it to one step, which is order of n. So TC can be order of n. How can we do? I just need to like include some space so I can have the TC as n. What I can do, I know something called hash map or hash set. They have lookup, lookup or search, or you can say find in order of 1. So they have constant searching or lookup. I can use this for my benefit. I can store this one, like I'll extend my first approach. I'll store all these elements. If I say I have created some set called 3, 4, minus 1 and 1. Okay. I increment like I have created a set. What I can do, I am just using my first approach. I need to start from 1. I can go till size of the array. I'll simply say, okay, in the first pass I created one hash set with this value. In the second pass, what I'll do, I'll iterate from 1 to size. Which number is not present will be above that missing number. So I iterated from 1 till size. I'll check. Okay, 1 is there. Yeah, it's there. 2 is there. 2 is not there. So 2 is our missing number. And lookup searching or finding that number is order of 1 in the hash set and hash map. So we have come to time complexity order of n, but we taken extra space. They say like we need to do in a constant space. We cannot use this one. We just need to take order of n time complexity and space complexity as order of 1. What next we can do? So I know one thing, if I not allowed to use the extra space, what I can do, I can modify the existing array. So if something is like 3, 4, minus 1 and 1, this was our array. If we are not allowed to use extra space, I just need to modify this one to do something. So let's think of something. Suppose we are we just take some extra space for now for just visualizing purpose. I've taken the extra space. This index is 1, 2, 3, 0, 1, 2, and 3. What I need to do, if you think or you have if you done the last question of yesterday, so it was like what we are doing, we are placing this number to its own position because we are given like number can range from 1 to n. Okay, number can go from 1 to n if we are asking the first positive integer missing number. So if I know it can have only positive number, I can arrange in this like their own index, or you can say on its position. So what I can say, okay, I'll ask 1 to sit its own position, 3 I'll ask to sit its own position, minus 1 I'll say, okay, go to your own position. But if you see, number is like starting from 1 to n and array are indexed from 0 to n minus 1. So what I need to do, I need to reduce one value from here. I can say, okay, now it's your own position. So what I'm doing, I'm taking 1, I'm just placing it to its own position. So 1 is going to minus. If I say, this is my value, go and sit to your own place. So I'll simply say, okay, go and sit to your own place, but your value will be offset by 1 because index are stored like start from 0. It can go to n minus 1. So I know the index is like 1 less. What I'll do, I'll place 1 to 0's index. Again, I have 3. I'll say, okay, 3, go to index 2, because you can have, your place is index 2. I'll say, okay, index 2 having 3. 4, I can say, go to index 3. Okay, I'll say 4, go to index 3. 1, minus 1 left. I can ignore this part, or I can say, okay, just for now, go and sit to your own any position. So I'll say this is my remaining position. I just sit here. Just for visualizing purpose, we'll not using this, but it is our base approach. So what I have done, I have asked the number to sit at its own index position. Okay, I got this. So what I need to do next? This we have done in order of n. I again need to iterate now. What we have done in this case, we have they created a set. We iterated from 1 to size. Same will do. We have placed this value to its own index. If you say 1 is now at index 0, 3 is not index 2, 4 it is index 3. If 2 was here, it will be on index 1. What I need to do, I need to compare, is the value in this array is 1 less the index. So what I'll do, I'll start my index from, if I say my index, I'll start the index from 1 to n. So what I'm doing, I'm going from 1 to n, you can say minus 1, or I'll say I'm going to index, or you can say I'm going from 0 to n, or n minus 1 for now. So what I'm saying, okay, for index 1, value can be 1. So if I say my index value should be equals to index plus 1. Okay. So index value should be equals to index plus 1. Right. If I say the array or the number value at that index, this is my index. My value should be 1 greater than the index. So index 0 should be index plus 1. Index 0 or index 1 need to be index plus 1. So if you see, if I say we have some table uh, like this, I have something, I have index, I have value, and I have my assumption. What I'm saying, index 0 element is, this is my element, index at 0 and element is 1. What I'm checking, it should be index plus 1. So index plus 1 is 0 plus 1. Is it equal? Yeah, it is equal. At index 1, value is minus 1. And we are checking it should be 1 plus 1. It is not equal. If I say for index 2, value is 3, it should be 2 plus 1. Yeah, it's equal. For value index 3, value is 4, it should be what? Index 3 plus 1. Yeah, it is equal. So I got like index, like position at index 0, it's not equals to what we have thought. So I'll show you code, so you can get like much, you can say, by seeing the code, you will be getting much what I am explaining here now. So I'll just simply write the code first. I'll increase my font. So what we are doing, like, we are simply like, what we need to do. I know my like, I just need to swap the number. So I need to know the size first. Size will be length of numbers. What I need to do, I need to have the index. What will be the first missing number, you can say, or for iterating I'm using index. I will say, okay, index can start from 0. What I'll do, index can go till size of the array. I'm just iterating over the array. I just need to swap the value. I can say, okay, it can go till size. Okay, I'll do use by while loop. I'll say, okay, iterate over the array. Why? I just need to see if the expected, I'm doing like, I just need to know the expected value or expected index. So if I say at index 0, the value was 3. So I'm just saying go to your its own position. So I'm saying, so value at that index, expected, I'll say expected index, what it can be, I'll say, okay, number at that index, number at that index. So number at that index says its own position, like number at this first case is 3. So I'm saying expected can be 1 less than the current number. So the expected index can be 2. Like I'm just saying number at 0 index, just go and sit to your own place. So I'm saying this is the place index. I'll say okay, place index, place index. I'll say okay. I'll also check if number is greater than 0, the number, current number. So I'll say okay, the number at that index should be greater than 0, should be less than equals to n, or you can say size, and what we'll see, okay, number at that index, if it is not equal to the expected, or you can say placed index, place index, what we'll do, I'll swap that element. So for swapping, I'll say I'll use some temporary variable. I'll say I'll store some of them, or I'll just simply use the Pythonic stuff. I'll say number at that index and the number at place index, uh, place index. Just swap your each other's values. I'll say number at place index. Go and place your value to the current index, and same I'll do. Okay, numbers at this original index. So I just swap the both value till the current value and the expected value. So I place like swap the place for that. If it is not a case, I just need to increment my index. Okay, if it is not a case, it is minus or 0, or if it is equal, I just need to increment my current index. I just what I'm doing, I'm just swiping this, swapping, swapping, swapping elements, elements in their own their own place. Okay, so I'm just swapping that number to its own place. Now I have the sorted, you can say, or swapped value. I need to iterate again from, I'll say index can go now till range of n, or you can say size of the array. I'll say okay, go till the size of the array and just check if number at that index should be equals to, if it is not, index plus 1. I'm just checking if number should be equals to at their index plus 1 value. If it is not, just return that index plus 1 as the missing number. Else at last, what I'll say, return the size plus 1. So if something is not found, or we have completely iterated the array, I'll say okay, return size plus 1 as our answer. So I'll just simply check if it is working or not. So I'll simply submit this one. So let's see it is working or not. So yeah, this is working fine. So that's all for today. Thanks for watching.